All right, good afternoon, good evening, ladies and gentlemen. Welcome to another series of online lessons. We are looking at AP Calculus. This is differentiation or multivariate calculus. So basically, we are trying to differentiate z with respect to t. Okay, if z is equals to this, okay, so we've been given that z is equal to e to the x y cos of x squared, and we're asked to find the z with respect to t. Now the problem is that z with respect to t, we don't have any t in this function here. And what we have to do, first of all, is identify the variables that we have in this function. We're going to call this function the mother function, which is what we are trying to get z with respect to t for. So we look at the variables that we have. Other than z, we have x and y and x again. So we have two variables, x and y. So what we're going to find the z dt, we are going to say, since z has two functions, x and y, we'll find first z with respect to x, then times, you get what is at the bottom here, so you say dx, then with respect to t. Okay? Because hypothetically, this means that the dx there and the dx there can cancel out, then we will remain with dz dt. Now, this is only from the x side, so meaning that we also need to add from the y side. So we say plus. Z also has another function, y. So we say dz dy times, again, dy dt. Okay, so this is how you create the chain rule. So from here, you just find the z with respect to x, you differentiate z with respect to x. Then here you need to find x with respect to t. So you differentiate x with respect to t. Same applies here, you differentiate z with respect to y. From here, then again you find y with respect to t. From here, then you are done with finding the z dt. Okay, so let's do this example. So first of all, we need to find z with respect to t. So we'll say dz z with respect to x. So we'll find dz dx. So when we differentiate, z is equals to e to the power x y cos x squared. So here we are only considering x. Y is considered as a constant. And since we see that x is both here and here, we need to use the product rule here. So to use the product rule, we're going to say this will be our u, and that is our v. Okay, that is our v. So we'll say dz dx will be equals to u prime v plus v prime u, where we differentiate u with respect to x because we are doing dx. So u with respect to x, remember how you differentiate the e function. You say you drop this power, which is x, y, you drop the power, then you differentiate this power with respect to whatever variable you're differentiating. In this case, we're differentiating with respect to x. So we differentiate with respect to x. Then we say times this function as well, which is e to the xy. So that is how you differentiate this function right here. Okay, so that is your u with respect to x, that is here. Then here you need to write your v. Your v in this case is cos x squared. So we write times cos x squared. Then there is a plus here. remember we're just finding dz dx, so there's a plus here, we'll say plus. Then now we'll differentiate v. Our v is cos. So we are differentiating v with respect to x. So differentiating cos with respect to x, how you differentiate? You just differentiate the inside. So the derivative of the inside with respect to x, that is 2x. Then you also differentiate cos. So when you differentiate cos, that will be negative sine. Then you just write what is inside here, which is x squared. So that is how you differentiate the cos function or the sine function. You do the same thing. What you do is you differentiate the inside. So the derivative of the inside, that will be 2x. Then you differentiate cos. What is the derivative of cos? That is negative sine. Then you write back what is inside. So that is that. Then we'll write our u. Our u is e to the xy. So we write our, which is e to the xy. So we have found the, oh, here we've not differentiated this. So this has to be differentiated with respect to x. So differentiating this with respect to x will just be this. So what is the derivative of x with respect to x? Here we say 1, there's a 1 here, minus 1, which is just x to the power 0, so which will just be 1, then times y, so this will just be y. Then we write this y e to the x y, then cos x squared, plus we can multiply minus because of the negative that is there. Let's do it. So that would be minus. So that is minus because of the negative here. This times this, that would be negative 2x. Then we can write the e to the x here, which is e to the x y, then sine of x squared. All right, so we have found our dz dx, which is right here. Now we need to find our dx dt. So we are now finding dx dt. Okay, x, what is our x? X is equals to t to the negative 1 over 2. We've been given x here. X is this. So x is equals to t to the negative 1 over 2. How do you differentiate? You drop the power. So this will be equals to negative half. Okay, you've dropped the power. Then you write t to the power negative half minus 1. So you subtract from the power. You subtract 1 from the power. So simplifying that, we are going to have this equal to negative half t to the power, this will be negative 3 over 2. So that is the x dt. So we found our dx dt, so which is this part here. We now find dz dy. So dz, let me use a different pen. Let me use red. So we are dz dy. Again, remember z is equal to e to the xy cos x squared. So now again, here we can use the product rule. Okay, we'll use the product rule. This will be our u. This will be our v. So the product rule says z with respect to y will be u prime v plus v prime u. Okay, so u prime, you are differentiating this with respect to y, we're differentiating with respect to y. So u with respect to y, again, we drop the power, which is x, y. We are differentiating the power. How we differentiate e to the x, e to the f of x, when the function is there, we drop the power, then we differentiate that power with respect to whatever we are differentiating. So in this case, we are differentiating with respect to y. So we write, we drop the power, we differentiate with respect to y. Then we write e to the, we write the same thing, x, y. So that is how you differentiate this. Then you say times v. Your v is equal to cos of x squared. Then you say plus, which is this plus. Then you have v prime. So v, which is this. Now you're differentiating this with respect to y, because we are differentiating with respect to y. So v prime, you're differentiating v with respect to y. But do we have any y in this function? So we don't have any y in this function. So v with respect to y, that would be 0 times u. U is e to the x y. Okay. Then from here we simplify. So this becomes, so differentiating this with respect to y. So we're just concentrating on the y. So which will just be x. Then we have e to the x y. Then times cos of x squared. Then this times that will be 0. So it's as good as leaving it this way. So now we have found z with respect to y. Now let's calculate y with respect to t. So y with respect to t, we've been given y is equals to st. Y is equals to st. So how are we going to calculate y with respect to t? So what we're going to do is, we have, we know that y, let me use yellow here, y is equals to st. So now we need to find dy dt. So y with respect to t, we're just differentiating t. So how we differentiate, we say whatever power there minus 1. So this, when there is nothing there, it is to the power 1. So 1 minus 1 will be 0. Any number to the power 0, that is 1. So 1 times this will just be s. So dy dt will be equals to s. So now we have the derivatives. Let me just write them here. All right, so I have our 4 derivatives here, dz dx, which is that. We have dy dt, which is s, dx dt, which is that, dz dy, which is that. And now we should just get the formula, which is this chain rule that we made here. Then we replace in the variables. So let me just cut this. All right, so we'll just replace in here. So we'll say dz dt. Let me use yellow pen. Let me use purple. So I'll just say dz dt. Dz dt will be equal to dz dx, which is this right here. So which is, we put in brackets. So that is y e to the x y cos of x squared minus 2x e to the x y sine of x squared. Then we close the brackets like that. Then we write our dx with respect to t. So x with respect to t is here. We also put that in brackets. So that is negative 1 over 2 t to the negative 3 over 2. Okay, so we close the brackets. That is x with respect to t. Then there is a plus here, so we'll say plus dz dy. So z with respect to y is right here. So we put that here. So that would be plus. We put in brackets as well. So that would be x e to the x y, then cos of x squared. We close the brackets. Then we write y with respect to t. So y with respect to t is right here. So this is y with respect to t, which is just s. Okay. So now remember, we have been asked to find z with respect to t. So meaning that we shouldn't have. So we'll get our x. What is the value of x? What is x equal to? So x is equal to, according to the question, x is equals to t to the negative half, and y is equals to st. So we'll get this, wherever there is x, we'll put t to the negative half. and wherever there is y, we put st. So we'll say x will be equals to t to the negative half. Then y is equals to st. So we'll say but t is equals to negative half, and y is equals to st. So wherever there is y, we're going to put st, and where there is x, we put t to the negative half. So let me use white. So we'll say dz dt will be equal to y. Y is equals to st, so we put st there. So remember, this is in brackets, so we put st. Y is st. Then we say e raised to the power x. Our x is t to the negative half times our y times y, which is st. So we say times st. Then cos x squared. So x squared will be t to the power negative half, then squared like that. So we are squaring what is inside of the cos. So x squared, that is t squared. Then there is a minus there. There is a minus. Let me use these other brackets here. I'll just use circular brackets so that you don't confuse them. So let's use circular brackets. X squared. So then there is a minus here. We'll say minus 2 times our x is t to the negative half. Then e raised to the power xy. So xy, x times y, x is t to the half, t to the negative half, times y, which is times st. Then sine, here sine x squared. So put x in brackets, which is t squared, t to the negative half, then squared like that. So that is this part. Then times negative half. So let me just put it here. So there is this times negative half t to the negative 3/2, like that. Okay, so that is this part. Then there is a plus here. We have a plus here. So we'll say plus. Again, open bracket. X is t to the negative half, t to the negative half. Then e to the xy. X is t to the negative half times st, which is y, times st. Then we say cos x squared. So x squared, which is just t to the negative half, then squared. Then we close the brackets like that. Then times s, like that. And you have found your dz dt. So, but from here you can also simplify. We see that we can factor out some terms and we can simplify. So, but for now, we'll just leave it here. I just want us to learn how to write the chain rule properly and how to replace in the functions. But we'll learn how to factorize and simplify the function later, because the lesson is getting too long. So I want you to try this task. So go through as many times as possible, and I want you to try this task. All right, so do this task. So evaluate dz ds if z is equals to x cos xy and y is equals to st and y is equals to, oh, this is supposed to be x, sorry. So this is x and y. So this is, so evaluate dz ds if z is equals to that, y is equals to st, and x is equals to s to the power 3. So again, you are looking for z with respect to s, but when you look at the function z here, there is no any s. So you need to create what we did there, which is the chain rule. So you create the chain rule, then you evaluate these derivatives. So for now, I just want to see how you evaluate the derivatives, and we'll see how we get it from there.